bonding to the so the electronic effect, the size effect affects the CO2 reduction or the catalytic behavior of a given. There is also the surface. How does the surface of the material affect the carbon dioxide reduction? So you'll find that the various surfaces, if the surface has it been treated, it means we can anneal the surface. So when annealing, that is meaning heat treatment affects the structure of the surface, whereby different authors have also tried to look at the surface effect of various materials in terms of the CDS. Now, alloying, that's the composition and the electronic effect. For example, the composition of the surface affects the product selectivity of various materials. When we talked about the higher resolution transmission electron TM for copper, indium catalyst, that is the FFT, the images, as we can see there, we finally talk about the different surfaces of that particular material. Next, we looked about the comparison, that is the comparison of the main products on metal catalyst with the different composition. And we'll find that when you look at the cathodic electrode, the cathodic electrode is the composition of copper, indium, is it nanoparticles, that is 11.9, gold, copper, nanoparticles. We have tin on oxide drive the copper. So we'll find that these all of the different electrode has different potential, and the product here, the main product was the carbon monoxide. But you look at the what's the everything we do on in terms of material science, we always have what is called the motivation. What is motivating the motivational background? Now, why alloying nanoporous metal catalyst? You'll find that alloying metal catalyst facilitates in improving selectivity towards a particular product. Also, it helps to break the linear scaling relation. For us to break the linear scaling relation, we must use alloys and not monometallics. The nanoporous metal catalyst enhances mass transport within the porous channels. Then what do we do? For us to improve this, we need to optimize. There's need of optimization. In my previous studies, I worked on nanoporous copper indium and nanoporous silver indium. Kinetic mechanisms of mass transport. You'll find that porous structures, within the channels, those particular spaces which are calling the pores, there is those spaces can either be filled with either the liquid or can be filled with the gas. Then it affects the kinetic mechanisms of mass transport. That is the basic requirement for enhancing the catalytic. That is, we need the refined size in favor of low atomic coordination. Then the mass transport, is it the hydrogen, the formic or carbon dioxide? Then hierarchical porous metal, then we need to tune the thickness. Now there is this particular, the arc melting, which also I worked in various precursors for dealloying in order to make nanoporous materials. So the ones I worked on was I combined a ternary, that is silver, copper, indium in that atomic ratio, and also we have to get copper indium, then we need to have a ternary, and then to get monometallic copper, we need to have binary, that is silver, copper. And then when you do dealloying, you can be able to you remove one phase and then you get the other phase. Then for silver, to make nanoporous silver, we use silver aluminium. Then to get silver indium, we use the aluminium silver. And then we get nanoporous. And characterization look at the electrochemical reduction. We also give the Raman spectroscopy. In addition to the structure, we need to see how is the structure looking like. Then you use what is called the X-ray diffraction. For our structure, we calculated, we looked at the stability of the nanoporous copper, and we got particular, the main product was carbon monoxide and hydrogen. This is how the morphology was. This was the Raman spectroscopy of that particular structure, the surface, how it was looking like. Then that is that particular, we can get this paper, that is Godfrey Barasa et al., that's Electrochemical Acta 2019, which is talk about electrochemical training of nanoporous copper indium catalyst for efficient CO2 to CO conversion and stability. So you'll find that this structure is hierarchical. This is an example for hierarchical porous structure, which was I talked about in my introduction, that is on page 2, where I say the structure can either be hierarchical, can be dendritic, or can also be bicontinuous. And this was the EDS. We look about the atomic ratios. So partial current density for CO at a constant potential. So this is the partial current density for carbon monoxide. This is the partial current density for hydrogen. Then we also did what is called the in situ operant technique, that is the CV, the cyclic voltammetry at various CDR that at a scan rate of 20 millivolt per second. And then this was the redox peaks of indium at 0.34 volts versus reversible hydrogen electrode. We talk about the ACM, that is, we note about the surface electron microscopy. The ACM, that's the ACM micrograph, that's how it looked like. This was the EDS. And then to look about the TM image of nanoporous silver and the CDR, you'll find that we ended up what is called the core shell. So we have the core made up of copper and the shell made up of the Raman and X, this is figure 1A is the normalized intensity, that is versus the Raman shift in centimeter, and you'll find that that was before and also after. So this is the Raman, and then these are the XPS, 3D. So Raman spectra for that vibrational modes, the XPS spectra for copper and elements, and the defined XPS, that's copper 2D. You find that the copper the 0 and then the copper 1. And so these ones. Next slide, please. In our next slide, we have what is called the parametric efficiency for carbon dioxide reduction performance on nanoporous copper indium 2 as a function of potential, and you'll find and detect the liquid product. We have what is called the is catalyzed at different potential. We need to compare with the DMSO, which is used as an intermediate standard, and the formic acid is the only liquid detected from the electrolyte. So we can be able to use the DMSO for comparison, and then the formic acid is the only, we look at the chemical shift for formic acid, which means it's the one that is detected. There's no any other product, any other liquid that was detected on nanoporous copper. And we did the comparison for other studies. Differently. hours we go on this. Realize surface. So if the surface is dendritic, like copper, it is carbon dioxide, copper, indium, nano, and in mechanism of activation at the interface. Now, look at the mechanism of activation at interface. Then we have what is called the Tackle. We need to go at the Tackle plot. So, Tackle plot for carbon monoxide, we got the gradient of 1 or 2 millivolts per decade, and that's the activation, or which this one tells the reaction, what the mechanism here is the activation of. Then the catalytic activity, that's electricity and the stability for constrained nanoporous copper at CO2 is also evaluated here in that figure B. Then the CO1 and hydrogen periodic efficiency for nanoporous copper varies with the electrolysis time at constant potential as they vary with the electrolytic at various potential. So we selected for potential, that is the minus 0.4 volts, 0.45, 0.65, 0.75, and minus 0.95 versus reversible hydrogen electrode. And it also depending on the voltage. Now, we talk about the conclusion. That is the alloying. Alloying of B-band metals with the indium significantly of CO2 electrochemical reduction. Then enhancement is that can be attributed to the inhibition of hydrogen evolution reaction by alloying surfaces. Then these nanoporous metals, they hold identical convex and concave curvatures, which probably enhance the thermodynamic stability. Then the dynamic restructuring can be driven by some chemical reactions, manipulating and monitoring the surface composition, and the structure becomes important to understand the catalytic behavior. So nanoporous metals might be good candidate for electrochemical catalysis due to interconnecting and they produce conductive features. So despite despite the remarkable advances and research, you'll find that research finding is the metal alloy catalyst as well as our current research finding nanoporous bimetallics, and the current state of the high demand for the robust and scalable implementation of electrochemical activation of CO2 reduction process. We can recommend that many of the mechanistic studies depend on DFT, which I also talked up on the previous PPT, as an integral tool for predicting new materials properties. So look about the structure, the electronic and the optical properties can be calculated. But the exact distribution of additional element, that is by alloying element in nanoporous structures, need to be investigated. We need to clarify the computed DFT, that is density functional theory results, extra and sensitive and the direct experimental evidence like the in situ FTR and X-ray absorption fine structure spectroscopy still need to be carried out. And alloying introduces extra strain in alloyed material, that is strain formed on the surface after the alloying have still had to be further corroborated by using use of in situ XRD, in situ XR, and the spectroscopy in further experimental results undertaking. There are some I've just taken a sample of some published papers. That one is the one I've talked about. This one is the main paper I've talked about. That's electrochemical training of nanoporous copper catalyst for CO2 reduction, which was published in Electrochemical Acta in 2019. and some other papers are still under review, which I've restrained myself to talk about because the results are under review. So acknowledgement, I would like to thank the organizers of this ATAL Academy-sponsored online faculty development program on advanced materials and engineering, especially the patron, Professor Dr. Colonel Robas Bose, Director, advisors Dr. Sharmish Bose, HOD, that's the PMA, that's Department of Physical Sciences, Dr. Tapas Maiti, HOD, Computer Science and Engineering. I also need to thank the coordinator, that's Dr. Ashish Mishra, whom I've been receiving lots of correspondence from, and Dr. Philip Kumar, and all my fellow guest speakers. I appreciate you. So I said, I think from the introduction, I think you have been introduced that I come from Kenya. I encourage all of you maybe to one day to think of visiting, or some of you have already visited Kenya, where Kenya is one of is a great country in East Africa. It neighbors Tanzania, Uganda, South Sudan, Somalia, and Ethiopia on the north. So we have some national parks, that's the Masai Mara, the Tsavo, the Nairobi Park, where we have the big five, and you can come and also get the experience. Thank you. Thank you.
Thank you, sir, for a nice presentation.
Yes, welcome, sir.
Tanushree ma'am.
I hope I'm within time. I've taken 35 minutes, sir.
Okay, Tanushree ma'am, you can actually ask some question from the participant.
Okay, we can take questions. If anybody has any questions, you can just directly unmute yourself and ask, sir. I think we have time, so we can take questions. So in chat box, actually, I can't see any questions. So if any participants wants to ask any question, you can unmute yourself and you can ask questions. We can take one or two questions.
I want to ask one question.
Yes, sir, you can ask.
Godfrey, which package you are using for this DFT study?
Pardon?
We are talking about DFT study of your material. So, which package or which software you have used for this DFT study?
I'm talking about DFT. Hello, you are asking about DFT?
Yes, DFT study.
Yeah, DFT is in my PhD I did it my research. So we extend and to correct or correctors or the examiner results.
Sounding not clear.
Critical study, then you can do electronic structure, how they can localize it, electric structure. So if you want to look at the mechanical the morphology, then you can discuss them on the okay?
Okay, sir. Thank you, sir. Thank you.
I have a comment.
Okay.
Hello?
Hello?
Yeah, Dr. Godfrey Barasa, I have a comment. Very nice talk indeed, actually. I'm very much interested. This CO2 reduction from these porous materials is very, very interesting. So I would definitely like to, maybe we could, I'm the next speaker probably, and we can also have hear my talk, and probably we could get connected. Something. So let's talk about, yeah? Okay, very nice talk.
Thank you, thank you, thank you.
Tanushree madam.
Tanushree madam, you can start now.
Yeah, Professor Mishra has come. He has joined.
So I can unmute. I can exist. Okay.
Yes, yes.
Thank you very much. Thank you.
Thank you, sir.
Yes. Now the question is, if I'm allowed to share my screen. My video is not working. Is that true? That video is not supposed to work? Assis?
Yes, sir. We cannot see you. Your video is not working, but your audio is working.
Audio is fine. So does it mean that I don't have to use video or I have to use?
No, this is depend upon it is not mandatory to use the video. Okay.
I tried, but kind of it says webcam sharing logged.
Okay. I got it, sir. You just close the tab again. You rejoin. This will be solved. Problem will be solved, sir. You just close the all.
My voice is audible.
Yes. And you again rejoin. I think this problem will be solved.
So, should I start for the introduction?
No. Actually, sir. Hello, sir. Most probably he log out. After that, he will join. Then you can start, ma'am.
Yes, sir. Yes, sir.
Do you see the camera as well?
So it's still not yet
Visible, sir.
So the same way I get the same webcam sharing logged.
Same thing happening.
Yeah. The media could not reach the server. Error 1020.
Sir, would you please change the browser? I think you are using Safari, I think.
I'm using, okay, let me go to Chrome because I'm using this Firefox. So let me try to go to Chrome.
Google Chrome is right.
I just copy the same link and I can go ahead with the Chrome, yeah?
Yes, sir. And before that, sir, you close the tab.
Yeah, I'm closing. Just give me a second. Yeah, good. How's going everything? Just give me a second, please.
Okay, no issue, sir.
Yes, sir.
Hello.
Hello.
Hi.
So you are audible.
Yes. So I also switched on my camera, but at the same
But
time
still it's not coming.
it says the same one webcam sharing logged. So probably either it is, I don't think I am at the Chrome moment, and it says the media could not reach the server, error 1020.
Okay, sir. Alok sir, most probably sir has to allow the webcam permission. Alok sir.
I did already. I will close again, I will open again. Yeah, am I audible?
Yes, sir.
Yes,
Sir,
sir.
you are audible.
Sonu Sharma, then you can start now. Otherwise, how we can proceed? You can start
Okay,
the.
sir. Okay.
Okay.
Okay, anyway, I'm going to share my screen. So entire screen.
So now the session will be taken by Professor Yogendra Kumar Mishra. He's from University of Southern Denmark, Odense, that is Denmark. He will be talking on topic 3D tetrapods based smart materials for advanced technologies. Professor Yogendra Kumar Mishra is professor of MSO at Mads Clausen Institute, Nano SYD, University of Southern Denmark. Prior joining to SDU, he was leading a scientifically independent group at Functional Nanomaterials Chair, Institute for Material Science, Kiel University, Germany. He did habilitation in material science from Kiel University in 2015 and PhD in physics in 2008 from Jawaharlal Nehru University, New Delhi, India. In Kiel, he introduced a new flame-based process for versatile nanostructuring of metal oxides and their 3D interconnected networks. These zinc oxide tetrapods found many applications in engineering and biomedical fields, and additionally, they can be used as sacrificial templates to create hybrid and new materials in tetrapodal forms. At the Nano SYD, he is heading Smart Materials Group, which is focusing in the direction of developing new kind of green and hybrid materials for advanced technologies. He has publications more than 180 and citations more than 8100. His H index is 50. Now I will request sir to please take over the session.
Yeah, good afternoon, everyone. I'm very happy to talk about many greetings from Denmark, and thank you very much, Assis, for inviting me to give a talk about our material-based research into this faculty development program. I'm very happy. I hope if you are not able to hear me, please interrupt at any moment, or please disturb me. And if there is any internet connectivity problem, please let me know. So that I could continue from. So the image at the bottom, you could see this is a very nice campus, which is situated at the southern Denmark campus, kind of border. It is the border region between Germany and the Denmark. However, coming back to the topic, as was introduced, 3D tetrapod-based smart materials for the advanced technologies, I will try to give you a brief. Yeah.
Sir, your slides are not visible. Anyone can see them?
Yeah.
Alok sir, I think sir slide is not visible. Will you please communicate with sir?
Yes, sir. Yes. I'm trying to communicate. Sir, actually, your slides are not visible. You have to share those slides.
Is that okay?
is not coming.
joindhanush.com is sharing your screen.
Share your screen, sir.
I
Then
did. I did already.
Then you have to select the entire screen, kind of the entire screen or application window.
I did. I am sharing my entire screen and I have a full kind of presentation open here. I do it again.
Sir, actually, we are not getting that.
Is that okay? Is that okay?
Still, we are not getting, sir.
No, sir, it is not visible.
That cannot be because. Okay, let me switch to other platforms.
No.
Kolaghat,
Hmm.
can we instruct the sir to upload his PPT?
আমি বলছি দাঁড়ান। Sir, are you getting my audio?
Yes, I am getting your audio, but sharing.
I'm giving, sir, at the bottom of the screen, you are getting share webcam, then you will get share screen option. Beside share webcam button, there will be one button called share screen.
Yeah.
Click on that.
Are you getting now?
No.
Then you have to choose the entire screen option. Then you have
I am choosing the entire screen, and now I do start sharing.
you have to click on the share button. Share button will be there.
Yeah, I am there. Share button. As I choose the entire screen. So I'm sharing the entire screen. Allow. And do you see now?
Not yet, sir.
How can it be possible? That is not a good idea. Because I did it from both browsers.
Sir, another way I am trying to say, sir, please follow that one also, sir. Sir, at the bottom right corner, there will be one plus sign action button is there. At the bottom right side. Hello.
Along the bottom left.
এক্সিট করে আছে। তার সাথে টেস্ট হয়েছিল।
Sir, already leave the meeting all of them.
হ্যাঁ। তার সাথে টেস্ট হয়েছিল।
হ্যাঁ স্যারের সঙ্গে টেস্ট হয়েছিল তো।
হ্যাঁ টেস্ট হয়েছিল।
টেস্টে তো স্যার প্রেজেন্টেশন দিয়েছিল, নো প্রবলেম।
Again join. Sir, are you getting my audio?
Yes, I got it again. I restarted everything.
Sir, at the bottom left corner, there will be one plus sign in the screen.
Yes.
So click on that. Then upload your presentation.
Is that work now?
No.
Click on upload presentation, then you have to choose your presentation file. Then you have to upload that.
Okay, I'm also on the server basically. But did it work? Why it's not working? Hmm. Now?
No, sir.
No, sir.
You are sharing another application. Stop sharing. And
Sir, if this is not happening, then you upload your presentations.
okay, just a
Sir,
second.
click on the plus sign.
Here, no, Firefox is not showing somehow the plus sign. I have only these three windows for mute and the call, leave audio, and the share webcam, which is not working. And also, yeah, no, this actually these university laptops have somehow.
Sir, when we test these things, then all these things is coming fine. There is no problem.
Yeah.
For a testing session.
Yeah, testing it was working very well.
It is working. It was working very well. Then we cannot understand. Sir, another thing, just you below left corner there is a plus sign.
No, I don't. I don't see that.
Below left there is a plus sign.
No, I don't get that. So let me try again with another browser.
I think you just close all this tab. Again, you reopen this tab.
Okay, I'm closing it.
Close all these things. So.
আদারওয়াইজ স্যারকে এটা পিপিটিটা মেল করে দিতে বলুন আপনাকে, ডাউনলোড করে আপলোড করে দেবেন আপনি।
আরে স্যার ওই দিন অন্য কম্পিউটারে করেছিল এবং মানে অ্যাট এ গ্ল্যান্স উইদিন 5 মিনিট উই কমপ্লিট দ্য টেস্ট। সবকিছু স্যার দেখালেন তখন থেকে। এবারে এখন ইউনিভার্সিটি গিয়েছে, ব্রাউজার ডিফারেন্ট। Okay, sir.
Hi.
Bottom left there is a plus sign.
Do you see something now?
No.
How can it happen?
Otherwise, sir, one thing it may happen. You just mail your PPT. We'll upload it.
It's more than 200 megabyte.
Oh, more than now? No. Then actually it will be not uploaded. You have to share your screen. Otherwise, it is not possible.
Exactly, it's more than 200 megabyte.
No, it is not possible.
So that's all.
Then, behind the webcam, is there any button? Share your screen.
Yeah, I'm.
Behind the webcam, share webcam, there is another button.
Yeah.
Share screen.
Yeah, I am going to the share my screen. I am choosing.
After that application window, you just go to the window is what? Enter window, application window. Just you go to the application window. Then you select your PPT file.
I did it now. Do you see something?
No, sir.
How can it not work? I close more or less all the files now. Whatever is open on my laptop. Okay, these university guys are making a kind of high security stuff on the laptops. Somehow this is a university laptop.
Actually, most probably they are giving some permissions. So due to regarding some permission, this problem is arising.
I gave already, more or less. There is nothing now on my desk. My desktop is completely clean, everything. There's nothing. I just removed everything now. But still. There is no other way, Zoom, Adobe, or anything you are.
No, sir. Because actually all the participants, they are already entering this meeting.
I closed everything. It worked perfectly.
Actually, in testing day, it is work fine. So I say that there is no problem at the time of presentation.
In this window. Hello.
Another thing. Sir, you
Hello?
send me the PPT file. I will share. Sir, you
Hello?
send me. Hello, sir. Hello, sir.
Something you should do you see now?
No, sir.
What can happen?
Ragda.
হ্যাঁ
তা নাহলে স্যারকে বলি স্যার শেয়ার ইউর এন্টায়ার স্ক্রিন। অ্যাকচুয়ালি ওখানে কিছু মানে ব্লক ফক করে দিচ্ছে।
হ্যাঁ ইউনিভার্সিটি
এখানে কোনো কিছু শেয়ার হোল স্ক্রিন করুক, সেখান থেকে পিপিটিটা আমরা দেখতে পাই। নাহলে স্যারকে বলবো অ্যাটলিস্ট ইউ সেন্ড দ্য পিপিটি, আমি এখান থেকে কন্ট্রোল করবো।
কিন্তু অত বড় ফাইল 200 MB
না,
ফাইল
সেন্ড করলে আমি আমার এখান থেকে শেয়ারিং করবো আর
200 MB মেলে আসবে না তো।
হ্যাঁ, তোমার গুগল ড্রাইভে তুলে দিলে আসবে।
হ্যাঁ ড্রাইভে তুলতে হবে।
স্যারকে এইটা বলো তো এন্টার স্ক্রিনটা শেয়ার করো, সেটা ভিজিবল হচ্ছে কিনা দেখতে হবে।
একবার দেখে নি কি অপশনটা আছে।
অলোকদা,
यस বলুন।
স্যার যেদিন টেস্ট করেছিল স্যার তো পার্সোনাল কম্পিউটার টেস্ট করেছে, এভরিথিং ইজ ওকে। এখন এবারে ইউনিভার্সিটিতে গিয়েছে, ওখানে ইউনিভার্সিটি সেখান থেকে কিছু প্রবলেম হতে পারে।
অ্যাকচুয়ালি ফায়ারওয়াল ব্লক করে দিচ্ছে বোধহয়।
হ্যাঁ, আমি সেই কথা হচ্ছে, সে ফায়ারওয়াল লক করে দিচ্ছে, শেয়ারিং কিছু অপশন পারমিশন দিচ্ছে না, শুধু কানেকশন দিচ্ছে। কোনো কিছু ওখানকার জিনিস ডকুমেন্ট তোমার শেয়ারিং কোনো স্যার লাস্টলি বলতে হবে স্যার অন্তকে মেলে পাঠালে আমি এখান থেকে শেয়ারিং করবো আর কি। জয়েন করুক স্যার। সি
পার্টিসিপেন্টদের একটু অ্যানাউন্স করে দিন যে একটু ডিলে হবে।
কি
Hello. Hi.
Yes, sir.
Can you see now? Hello.
Yes, sir.
Is it okay? Visible?
No, 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 no. We cannot see anything. Only your audio is come.
No screen?
No screen, sir.
I have said I changed now different computer system. How can this happen?
Actually, sir, this is also in your actually university campus system is.
No, I am at the home now.
Actually, previous day you use the system where we make all this testing.
I tried the same system actually today.
But our screen is visible to you.
Yes, I can see your screen. This is sponsored online FDP.
Or
Yeah.
another way, sir, if it is not there, you can send the document to me so that I can share the document if it is possible to you.
But it's more than 200 megabyte. I do not know how to share. So should I?
Full drive actually you can easily share it. But why your screen is not sharing, we don't know. Sir, another time you try it. You can share screen if you do it.
It's unbelievable. I do not know why. It should never happen. I did it so. I have done so many talks and I do not know. I am clicking directly the link you gave me last week. Yeah.
No, no, this is a link, not this. Actually, yesterday I sent you one link.
Sunday. Yeah. This link.
Okay, actually link is fine because your name is, we also join the same link. You are also audible, no problem. But why sharing screen is not coming, we don't know.
Because now I changed to completely new Windows system here. I'm only entering email address. I don't need to enter anything else.
The name is sufficient, sir.
Do you see something now?
No, sir. No, sir. Sir, actually, I'm trying guiding a little bit. So
Now?
please follow those steps, please.
Yeah.
So please click on share my screen.
Yes.
Then at the title bar, it is showing entire screen.
Yes, I
Application
did
will
it.
show, what
Yes.
you are getting. Entire screen.
Yeah.
So
I am sharing the application window.
then choose your PPT file.
Yeah, I have chosen.
Then click on share.
Yeah. I did it already.
So it should come, but still we are not getting why it is happening.
Yeah, I can see here the display. I can see my display very easily on the PowerPoint. So, how come it's not a good idea? This should not happen. That day it worked properly, and today, even now, I'm completely from the Windows system. No, the camera is not. It's hanging. That is definitely some problem. I do not know what kind of.
Sir, last moment, a few seconds back, we see your screen, sir. Hello? Hello, sir.
ওটা আমি করেছিলাম, আমি দেখছিলাম হচ্ছে কি
তুমি চেক।
আমার তো
আমার ঠিকই আছে তো, আলোকদা?
হ্যাঁ, সিস্টেম ওকে আছে।
সিস্টেম তো ওকে আছে, মানে পোর্টাল তো তোমার ধনু পোর্টাল তো ওকে আছে তার মানে।
হ্যাঁ, সেটাই
হ্যাঁ,
দেখবো
পোর্টাল
বলে আমি চেক করলাম।
Something is coming now. Hello?
No, sir. No, sir.
Now? No?
No, sir.
Hello, sir.
Yeah.
Yes. Now you share your screen, sir.
I shared it. Now, do you see that?
No, sir. No. Again, same problem is arises. Same problem.
This is my third laptop now I tried. I don't know what to do. It's a third laptop I'm trying now.
So, sir, if you send me the PPT, okay, I will try. If it is possible to you.
Yeah, I can, but then I have to make a kind of reduce the size or something.
No. Directly you can same size. You can in Google Drive. You can use it. What is your no? You have Google Drive or not? So can you store your file all this PPT file in some drive?
An error has occurred with the screen sharing. Please try again. Hello?
Hello, sir.
Is that work now? No.
No.
Okay, then I am sending you PDF file. This is not good.
Okay.
Sorry, I do not know why it's not working. It should work.
Okay, you just send it to me, then we can do it. Sir, which mail address you send it?
Just a second.
And just enter screen. Okay. Actually, there are so many things. Stop working. There are so many stops. There are so many slide is opening. Why this? Okay, this is coming, sir. From there you have to check your print.
What?
Just before few minutes back, it is we see your whole screen, sir.
Now you see?
No, again not.
Again?
No, sir.
Do you see now?
No. Sir, what is the size of your PDF? Size of your PDF?
Actually, I have lot of animations into the slides. The problem is that otherwise I would have done it.
দিলীপ স্যার আমি বলছি একটু
Yes.
Sir, please click on share my window screen. So before that, please open the PDF PPT file. Please open the
Yeah,
PPT.
I opened basically, and only then I am sharing.
Okay, now click on share my screen.
Yeah.
Then click on application window. At the top there will be three items are written. Please click on application window.
Yeah,
Then under that you will get your PPT file.
Yeah, I did that, but
click on that.
Yeah, I did that.
Click on that, then click on share button.
Okay, just a second. I go again. Give me a second. It should not happen.
Under application window, you should get your PPT file open window. Click on that PPT file, then click on share.
Just a second again. I'm trying. Yeah, so give me a second. Yeah, tell me again.
Click on share my screen.
My PowerPoint file is open.
Yes. Then
Okay.
Click on share my screen.
Yes, I am at share my screen. Then it says, will you allow join this cam to see your screen? And here we have window or screen to share. So I have select window or screen. What should I do?
There should be one written application window is written over there. Entire screen, application window, and tab.
I can see entire screen. I can see the talk as well.
Application window. Are you getting application window?
No, I do not see the application window. I directly say get window or screen to share. So let me, okay, that's fine. I choose again. And then it says, what is this? Allow, I am allowing it. Hmm. Do you see anything now?
No, sir. No, sir.
Okay, wait a second.